So today we're going to talk about squares and square roots. We're going to start with a couple of definitions, and the first definition is square root. Now you got to remember, when we talk about squares here, I don't mean the shape of square. Squares mean the answer you get when you square a number. Those are the squares we're talking about today. So square root, definition of that, you can see right here. If m squared is equal to n, then we say that just plain old m is the square root of n. So I'll give you a couple examples here to show you what we mean by that. If I have the number 36, I know that that is equal to 6 squared. So that means we can say that 6 is the square root of 36. Okay? You could also say if I had 64, I know that is equal to 8 squared. So that tells me that 8 is the square root of 64. Now, there's something we have to remember when we're doing this, is that there's actually 2 different numbers that I can square and get 36. Not just 6. Think about it for a second, pause the video, see if you can think of another number that when you square it, you still get 36. Okay. If you take negative 6 and square that, that means I'm doing negative 6 times negative 6. When I multiply 2 negatives together, I always get a positive. So negative 6 squared would also give me 36. So there are actually 2 square roots for each number. There's a positive square root and a negative square root. So down here we could say the square root of 64 is 8, and so is negative 8 is also the square root of 64. So that's an important thing to remember, is that every number has 2 square roots, a positive and a negative. Now, mathematicians are pretty lazy people, so we don't want to have to write out every time that we're looking to find the square root. So they came up with a symbol to mean find the square root. That symbol is called the radical sign. And there it is. It basically looks like a division sign with a check mark out front. And when you see that sign, this one right here, that means to find the positive square root of the number that's underneath it. Okay? Anytime you see the radical sign, that means to find the positive square root of the number that's underneath it. I'll show you a couple examples in just a second. And one more definition is a perfect square. These are the squares that we're talking about. A perfect square is any number that has integer square roots. So 36 and 64 would be perfect squares. They have integer square roots. Square root of 36 is 6 and negative 6. Square root of 64 is 8 and negative 8. So if you want to get your list of perfect squares, what you're going to do is take each of their integers and square them. And here you have that for the first 20 perfect squares. you need to take a minute and copy these down, because you need to memorize the first 20 perfect squares. So the number in the left column is the integers, 1 through 12 right now you can see on the screen. And what you get when you square them, this should be x squared, not just x2. What you get when you square them. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. Most of these ones we should already know, definitely up to 10, maybe up to 12. Go ahead and pause this, copy these down. Okay, now I'm going to scroll this down, and so you can get the rest of these copied down. These ones you probably don't know as well, but again, you need to get these ones memorized. Your life is going to be a lot easier if you have these memorized. There's several different problems where we're going to be using square roots. If you know your square roots, it's going to be much easier. If you don't, it's going to be very difficult to do these problems. So you need to memorize them. We will take a quiz in a couple of days on the fact that you do have these all memorized. So make sure that you do memorize them. Go ahead and pause this if you don't have these all written down yet. Get the rest of them copied down so you have them to study from. When you're done, go ahead and play it and I'll move on. Okay, so now that we know all of our perfect squares, it makes it easier to find the square roots. Remember, when we see this radical sign here, this tells us to find the positive square root. So the positive square root of 49 is 7. Now if they want us to give the negative answer, what they'll do is they'll put this negative sign out front. That means give the negative square root of 121. If you don't know what that is off the top of your head, for right now you can go back until you have these memorized and look at your chart. Here's 121. It came from squaring 11, so that would mean that the square root of 121 is 11. So if they want the negative square root of 121, that's going to be negative 11. Pretty easy. Okay? They just give you a square root sign, you give the positive answer. They give you the negative square root sign, you give the negative answer. If you don't have what's underneath, you don't have it memorized, so what you square to get that number, then until you have them memorized, you have this chart to go from. Okay? And you just go through this chart, find your number, find what you had to square to get it. Okay, now you can see that between 0 and 400 there were only 20 perfect squares. Every other number between 0 and 400, the other ones that are on that chart, when you take the square root, it doesn't come out to be an integer. It comes out to be a decimal, a very long decimal. And so what we're going to do is approximate. If you look at this, to find the square root of 45. Well, 45 wasn't a perfect square. It wasn't in our list. So that means it would come out to be a decimal. The only way to get specifically what it is as a decimal is to use a calculator. And I will show you how to do that tomorrow in class to make sure everybody knows. But we can still approximate what this is. And the way we're going to approximate this is you find the two perfect squares that 45 is between. Okay? So I go to my table and go back there real quick. I look on here and find, well, what would 45 fall between them out of these perfect squares? Well, 45 is going to fall right in here. It's between 36 and 49. And so what we're going to do to approximate is say, okay, well, we know 45 is between 36 and 49. So what we'll use for our approximation is whichever one of these it is closer to. Obviously, if you look at these, 45 is closer to 49. So we would say that the square root of 45 is approximately the same as the square root of 49. So the square root of 45 is approximately 7. Okay? That's how you do approximate. You find the two perfect squares that this number is between, pick which one is closest to, and use that square root as your approximation. Alright, one more thing we need to do with squares and square roots is we have to be able to solve equations that have them. Now, if you remember, when you solve equations, you always just do the opposite. Okay? Well, the opposite of squaring is taking the square root. So, what I'm going to do here to solve this, to undo squaring, I'm going to take the square roots of both sides. Remember, whatever I do on one side, I've got to do on the other. And so, the square root of x squared is just x. Now, normally when we see the radical sign, that meant to just give the positive square root. But that's when you are given the radical sign. If you put it into the problem, you have to give both answers. And the short, easy way to do that is you write a plus sign and a minus sign over top of each other, and you read that plus or minus. And then, if you don't have it memorized, you go back to your chart and you see that square root of 169 is 13. So what this tells us when we solve this is I can plug either positive 13 or negative 13 in for x up here, and I'll get 169. Which of course is true. 13 squared is 169, negative 13 squared is 169. So when you're solving equations, you always do the opposite. Opposite of squaring is take the square root. When you put in the radical sign, you have to give both answers, and you do that by putting a plus sign and a minus sign above each other. This is our solution to that equation. X is plus or minus 13.